opportunities to improve research in all fields. One of them is medical field. Accurate classifications in medical data is really important because of its impact on disease detections and patients' treatment. Fortunately, machine learning can help us in classification problems on a large dataset. But we still have to make the development. I am Ilsha Wirsati, who would like to present you a paper that titled A Comparison Sum of Kernel Functions with Support Vector Machine Classifier for Thalassemia Dataset. And I want to introduce you. I am the first author. The second author is Professor Zuhair Manusta. The third author is Miss Jenny Eva Aurelia. The fourth author is Miss Rihartini, and the fifth author is Miss Glory Stefani Sari. My talk will be in 5 parts. The first part is introduction, the materials, methods, results, and the final part is the conclusion. And let's now turn to the first part. Introduction. First of all, I would like to give you some information about why thalassemia is one of the main public health problems. There are 7% of the world's population as carriers of thalassemia, with a death of about 50,000 until 100,000 children. In my country, Indonesia, currently thalassemia ranks 5th among non-communicable diseases after heart disease, cancer, kidney, and stroke. With the number of carriers 3.8% of the entire population in Indonesia. So now I want to explain about thalassemia. Thalassemia is genetic disease because of blood disorders inherited from family. The cause of thalassemia is the mutations in the DNA of cells that make hemoglobin. As you can see in the picture, thalassemia sufferer's body makes an abnormal form of hemoglobin. And the result is the deficient amount of the hemoglobin. Hemoglobin allows red blood cells to carry oxygen. When there's not enough hemoglobin, the bodies of red blood cells do not function properly and they die more quickly. Hemoglobin is made of 2 different parts. You can see in the picture, there's alpha and beta. Therefore, there are 2 types of thalassemia, alpha thalassemia and beta thalassemia. And we have to look at the next part. In this second part, I will talk about the materials. This research used Thalassemia Dataset from Harapan Kita Children and Women's Hospital in Indonesia, and it consists 150 samples. You can see in the table, this is the example of the data. You can see there are 10 variables as featured and 2 classes. Thalassemia patients defined as class 1. Also, the authors utilized the Support algorithm to assess the normality of the distribution for the feature. A bar plot is then drawn, showing the relative ranks of each feature. You can see the plot counts has the highest ranking. And now let's move to the next part. Methods. I would like to start with general information about Support Vector Machine. Support Vector Machine idea is mapping from input space to a higher dimensional space. SVM constructs a maximal spread hyperplane to spread data into classes. And this is the illustration. And now we will take a look of the detail of the illustration. We can see there are 2 classes. The red dots as positive class and the blue dots as negative class. And there are 3 hyperplanes. H1 in the blue color, H2 in the red color, and an optimal hyperplane in the black color. The next slide is the formula of SVM. We can see the problem of SVM optimization can be written as follows, where W is weight vector and B is bias. By solving the optimization problem, we can get formula of weight vector and bias. And then we substitute the decision formula of SVM. However, there are classification problems where we cannot using a linear boundary decision. That case is nonlinear separable data. The best way to approach nonlinear decision boundary is to expand the original feature space, but it makes computations intractable. To tackle the issue, we applied kernel trick using kernel functions. This is the kernel function. And then, the problem of SVM optimizations will be as follows, where the epsilon symbol is select variable and C is the penalty. By solving the problems above, we can get formula of weight vector and bias. This we substitute to decision formula of SVM. In this research, we propose three kernel functions: linear, polynomial, and Gaussian radial basis kernel function. The first one, linear kernel. Linear kernel is the simplest kernel function. The results of learning algorithms are often equivalent with support vector machines without kernel function. The second one is polynomial kernel. There is D as the degree of polynomial. High degree increase the complexity of classification model. And the last one, Gaussian radial basis. There is sigma as parameters that defines which kernel. By comparing this kernel, the expectation is we know which kernel has the highest accuracy. To calculate accuracy, conversion matrix is used. This is the table of conversion matrix. There is TP or true positive, FP as false positive, false negative, and true negative. Now, take a look at the formula. This is a formula of accuracy, precision, recall, and F1 score. And now, I would like to move on to the next part. And this is the results according to our experiment. This research is training data differs from 10% to 90%. For Gaussian radial basis kernel, we use sigma 0.1, and for polynomial kernel, we use degree 3. This is table 1, the accuracy and F1 score of SVM with various kernel functions. We can see, for the accuracy, SVM with Gaussian radial basis kernel is the best one, with an average accuracy 99.63%. The second best is linear, and the third one is polynomial kernel. For F1 score, the same as accuracy, Gaussian radial basis kernel is the best one, with an average 99.78%. And now, let's move to the table 2. This is table 2, the precision and recall of SVM with various kernel functions. We can see the Gaussian radial basis kernel still has the highest average of precision and recall. And now, finally, we have to move to the final part. And now we arrive at the conclusion. Support vector machines with Gaussian radial basis kernel functions is the best one to classify thalassemia datasets from Harapan Kita Children and Women's Hospital in Indonesia. And now, to make it simple, I made a table. You can see the rank for accuracy, precision, recall, and F1 score. There's the differences in recall. Polynomial kernel is in the second place, while linear kernel is the third place. For future research, use a larger dataset is very recommended. Also, we believe the future research can modify or develop this method to give the best accuracy for predicting or classifying the other diseases. And thank you for your attention.